everyone for joining the 5th instalment of the QUT Centre for Data Science Under the Hood seminar series. My name is Chris Ravandi and I am one of the core team members for the centre. It's my pleasure today to introduce our speaker, Sander Leemans. So Sander is a lecturer at QUT in the School of Information Systems, and his research interests include process mining, process discovery, conformance checking, stochastic process mining, and robotic process automation. In particular, he specializes in making solid academic techniques available to end users, analysts, and industry partners. So today, Sander will be talking to us about process mining, practice, theory, and future. So Sander will talk for about 40 to 45 minutes or so. And then at the end, there should be some time for questions. But if you've got any questions in the meantime, please don't hesitate to start throughout the presentation, typing them into the Q&A box down the bottom there. And it would also be good if you could just make sure that you keep your microphone on mute. Okay, so now I'm going to pass it over to Sander.
All right, thank you, Chris. Yeah, just to reiterate, if there are any questions during my talk, feel free to jump in and ask. I'm gonna have to close this Q&A thing, but I hope either Chris or Joyce will tell me if there are any questions there. So yeah, please feel free to jump in the middle. I would say that the best thing that can happen is that I run out of time because of questions. That's the best that can happen. As Chris already said, I'm gonna take a little bit of your time to talk about process mining. We're going through practice, theory, and future. But of course, I will first tell you what we actually mean with process mining, and then we're gonna look into the other areas. Now, before I go into that, a little bit about myself first. I started at QUT in 2016 with Mo Win and Arthur ter Hofstede in the Information Systems School. And before that, I have had quite a educational career, ranging from 2 masters and a PhD in Eindhoven, the Netherlands. So you could summarize that I am an academic. Now, the one little anecdote about my teaching master was that it was actually a collaboration between 3 universities in the Netherlands, Eindhoven, Delft, and Twente. And the last 2 I have never actually been to. So I've never logged onto their systems. So it was all at Eindhoven, but I still have a diploma from 2 universities that I have never actually attended. I've been at QUT for roughly 4 years now, and you might know me already a bit because I am a warden. So at some point I might have kicked you out of the building and not let you in again until it was safe to do so. These things tend to haunt me. I've had weeks with 4 evacuations in buildings where I was just for half an hour and then the exercise was there. Every now and then I spam the whole SEF department with LaTeX templates for exams and that kind of thing. So I'm a huge fan of LaTeX, so you might know me from that. And finally, a year ago or so, I got a photo on the monitors on campus at the entrance of buildings, and it took me a while to get them off. So you might know me actually already quite a bit. Before I go into more about work and research stuff, one more thing about me, and that is I like to volunteer to educate children, both in terms of judo. So I am a national referee and actually the head referee of Queensland in judo. And I assist or I volunteer in STEM promotion, science, technology, engineering, and math. where groups of, let's say, high school kids build a robot from Lego and then go to a tournament day, and then there's a lot of noise and a lot of fun and a lot of positive energy to engage them with STEM. So yeah, we of course always dress up a little bit silly, so it's that, you know, a big serious guy doesn't look so serious anymore, and we are a bit approachable for the smaller kids. So that is in a nutshell a little bit about myself. Let's move on to process mining, the core topic of this seminar. In process mining, our whole subject of study are processes. So a process can be either an insurance claim that is being handled, or orders that are being shipped, or HR performing in the introduction on a new hire. All of these are processes. Now, the problem we're trying to solve with process mining is that often it is not well known what is actually happening within this process. So if people are working, what's the performance of the process? What does it look like? Does it adhere to certain rules and regulations? That are the kind of things we would like to unearth using process mining. So our end goal in process mining is insights such that these processes can be improved. Now, how do we do that? First of all, nowadays, a lot of processes, or basically every process, is supported by an information system that records every step that is being executed for each claim, order, or whatever, into an event log. This is our basic assumption. And again, our goal is to derive insights into the performance and conformance of the process based on this event log. First step is to discover a process model. A process model will describe the behavior in the event log for each trace or case. Now, later on in today, I will show you that this is not a trivial problem, and there are a lot of trade-offs and caveats to be considered. So whenever process mining is being done, it's a very good idea to check the conformance of the model that was found with respect to the event log. Also, conformance checking might be used to check for regulations, whether the behavior that is happening in real life in the organization actually matches the designed behavior. You can use conformance checking for that. Then finally, a process model by itself is only describes which steps can happen and in which order, but it does not really show any performance yet. So an enhanced model takes a process model and enhances or annotates it with extra information such as timing, bottlenecks, and so on. This is the basic flow of process mining. More advanced topics within the process mining field are recommendation and prediction. So can we predict what a case that is halfway is going to do next, or whether it will be on time, or whether it will meet a certain SLA? And can we recommend steps in order to bring a case forward to optimize against these things? This is in a nutshell what process mining looks like from the inside. Now, an event log. What does that look like? As it is our input in process mining, we need such an event log. Well, here we have an example simply from Excel. There are several columns, and the columns we need are case ID, activity, and a timestamp. So the case ID will tell us which case this particular event was executed for. So each line in this Excel file is one step that was executed for one case. And the case can be, again, a customer, a claim, and so on, or an order. Now, with the case ID, we can reconstruct the steps that were taken for a particular case through the process. and the steps themselves are shown in the activity column. So here we see a submitted, a partly submitted, and so on. These are the actual steps that were being performed. Now then the complete timestamp tells us when this happens. So with these three columns, we have enough to do process mining. However, there is more information in this event log that can be used. For instance, the resource will tell us who executed this step in the process. So that might be useful for social network analysis. Here we have another column called amount requested. This is an event log derived from a mortgage application process in the Netherlands. And this column shows us how much mortgage was requested. And again, this is not strictly necessary to apply process mining, but we can still use it to our benefit. Finally, lifecycle transition shows us whether this particular step denotes the start or the completion of the event. So we do not strictly need this again, but it might nevertheless be useful. This is the input of process mining, and this is the only input of process mining. So everything else that I'm going to show you today is derived from this event log using algorithms, using software. The first step in process mining is to find a process model. So we refer to this as process discovery. And I already hinted at it, this is not a trivial task, and there are several trade-offs and caveats that need to be taken into account. So let's look at these challenges in a little bit more detail. So why is process discovery difficult and therefore also interesting? Well, in order to do that, one difference between process mining and other types of data mining is that a process model needs to be read by humans. So yes, there are automated techniques like conformance checking and enhancement that can make use of process models, but the main use of a process model is for a human to look at it, an analyst to look at it, and then find issues in the process and hooks to later on improve on. So what makes a model good? Well, first of all, it needs to be sound. That means that it must have a well-defined behavior, the model. And in a minute, I'm going to show you an example where this is violated. So there are actually process discovery techniques that do not produce models that have a well-defined behavior, which makes their further use very challenging. Second, up till fifth, there are 4 forces in process mining that determine whether a model is good with respect to an event log. So think of a plane here where 4 forces work on this plane and drag it in different directions. So first of all is fitness, and that in this image that goes up. So fitness means can every case that I see in the event log actually be replaced in the model? To the right, we have precision, and that means that the model describes only the behavior in the event log and not much more. So if a model has a bad precision, that means that it allows for too much behavior, and that makes it less useful for analysts because it is less precise. Then down is simplicity. So as humans look at models, we want the model to be as small and as neat and as clear as possible. And finally, generalization forward means that, yes, we have the event log and maybe you can replay it, fitness, but is behavior that is recorded tomorrow also still supported in the model? So we do not want to be overfitting, and we do not want to just describe the behavior in the event log. We want to get, let's say, the real behavior of the process. Now, these 4 quality criteria are very often competing, and given real life event logs from actual industry partners, we have seen that that in some cases it is very difficult to find a model that does well on all four of them, or even impossible. So they are really competing. Now, related to the actual process that is running and our model that describe it, a formal property called rediscoverability says that the process model it describes the same behavior as the process that it was derived from. If a discovery technique is able to guarantee that under some conditions, then we say that the technique provides rediscoverability. So the behavior in the process is exactly rediscovered by the discovery technique. And this provided a very solid formal base for techniques. So it's not just the best effort or even random. No, it is, there are actual guarantees that, and we know in which cases these algorithms work well. So that are the quality criteria that are sometimes competing. So what makes a good model? So how can we get one? Well, in the beginning days of process, let's say business process management, human modeling was and still is a very, very well-known and well-established field in business process management. So that means that usually a consultant goes to a company or an organization and interviews people to discover what they are actually doing. But this is, of course, a lot of work and pretty much always biased, because people don't tell you what they actually do. No, they tell what they're supposed to tell you. So using process mining, we can get this human step out of the loop using algorithms. Now, some of the old algorithms are nowadays considered toy algorithms. And here at the bottom, we have a model from such a toy algorithm called the alpha algorithm. And this model, it is a battery net, and the precise notation and semantics are not really relevant for now, but this model is not sound. It does not have a well-described behavior, because all the boxes that we see on the top, like W, nabellen, incomplete dossiers, start and complete and so on, all of these can happen at any time. So they are not limited. With that, the behavior of this model is not well defined. Second category of discovery techniques are the optimization approaches. So these take the structure of a battery net and try to fill it up such that certain criteria are optimized. So for instance, the miner that I've shown a model of here optimizes precision without violating fitness. So this model is guaranteed to be fitting and as precise as possible. However, you immediately see the downside. It is too complex. No human can look at this model and discover new things that they didn't know yet about the process. This violates simplicity, and yeah, in general, these models are not very useful. Then there is a whole bunch of commercial tools, and these tools usually produce very good models in terms of fitness, precision, and simplicity. However, their semantics are not well defined. So we see a picture here, and intuitively it's very clear that any case walks from the top over the boxes and the arrows to the bottom. But things like concurrency and choices are not really well defined here. Then finally, there are constructive approaches, and I've done my PhD on them. And I'm actually going to show you a constructive approach in a minute. Advantages of constructive approaches are that they produce sound models at all times, and that they can offer guarantees, for instance, fitness or precision. downside is that they might then sacrifice other quality dimensions to do so. So process discovery, in summary, it's not a done deal. There are several techniques, I think around 50 different process discovery techniques, and all of them make a different trade-off between these 4 quality criteria. And this also makes it quite different than other areas of data mining. So now let's look at process mining in practice. So we've seen the theory. One tool that I would like to show you that is being developed here at QUT is the visual miner. And the visual miner supports this part of process mining. So you give it an event log, it will discover a model, it will allow you to check the conformance of this model against the event log and enhance it with several performance measures. This tool, the visual miner, is used for process exploration. So given an event log, the question we're trying to answer is, what is the behavior that is going on in this process? And are there any things that stand out? So this tool is meant to be used by an analyst, a human analyst that uses it to zoom in on particular aspects of the log using filters. And all the other steps are also available. And actually, this tool is free and open source, and please see visualminer.org for more information. But for now, I would like to give you a demonstration. This is always a little bit risky. So before I go into the visual miner, I would like to show you the input, which is an event log. So in this visualization, on the left, under instances, we have a list of all cases that went through this process. And this process, again, is a mortgage process, a mortgage application process from a financial institution in the Netherlands. This is public data. And each of these instances represents one application. In the middle, we see the events that were executed for this particular application. So in this case, there were 4 events ranging from submitted to cancelled. Each of these events can have other attributes that we already saw. For instance, the resource 112 is the resource for the first 3 events, and some other information just like timestamps. So again, this is our only input. Now then we start the visual miner. Now a couple of things are going to happen quite quickly. So first of all, it's going to discover a model. That's done now. And after that, it has performed conformance checking, and that has also finished before I could even finish my sentence. So this is the visualization of a process model that we're now looking at. There was no input from my side. This just comes from the log. Now, how should we read this? Let me zoom in a bit. Every case walks from the green dot over the boxes that denote the activities to the red dot on the end. And in this case, the numbers indicate how often that part of the model was executed. Now this already shows to industry partners in quite a bit of detail what is going on within the process, because this is unbiased. This comes from event data. So this is already an eye-opener usually. Now, given that we had timestamps in the event log, there are several more types of analysis we can do. One of them that I would like to show you is performance. And if we enable path and sojourn time, now every box, every activity is annotated with how long it took till from the end of the previous activity to the end of this activity. So for instance, for A approved, we have an average sojourn time of 16 days, and that means, let me zoom in a bit, that from the end of A finalized to the end of A approved, 16 days passed on average. Thanks to the coloring, we immediately see in this process that A approved and A cancelled are the steps in the process that take time. Now, given that we have timestamps, we can also animate the cases in this process over this model. So now every yellow dot that flows over this process is an actual case as it happened in reality. One final thing I would like to show you on the visual miner, and there are heaps and heaps of more functions, but this is not, of course, a tool demo. One thing is we saw already that process discovery tools have to trade off between quality criteria. And one of the trade-offs is how simple do you make the model? How much, in other words, how much behavior do you leave out in order to make the model more readable? Now, a lot of commercial tools cannot show you the behavior that was filtered out in order to make the model more simple, but the visual miner can. So if we change this to paths and deviations, now the view is updated to show not only the behavior that is in the model, but also the behavior that was left out. So for instance, here we see that in 183 times, A approved must have happened according to the model. However, in the event log, it was skipped. On the other hand, here a bit to the right, we have a little self loop. So in 465 times, at this point in the process, the model said you have to do A registered. However, in reality, something else was executed in addition at this point. And if we put our mouse on it, we can see that all of 465 times was the activity A activated. So using these techniques, we can find deviations. We can update the model. We can change it to reflect certain rules or certain ways of working that we want to check. And then the deviations will tell you where reality deviated from your example. So that was the visual miner, and again, it's free, open source, and in full development. And we have actually applied it in industry already quite a few times. So for the sake of time, I'm going to skip a few here. And I'm going to highlight a few. So using process mining in 4 South Australian and Queensland hospitals, the BPM group here from QUT, chaired by Mo Win, we found that there was several differences in frequency and timing in the emergency departments of these 4 hospitals, depending on at what time you presented there. So yes, at day and night, you get a different type of process in an emergency department. Also, we found that these hospitals treat people with different symptoms, with similar symptoms differently. In Suncorp, there was the process that was studied was commercial insurance. And thanks to process mining, which was used to find bottlenecks in the process, the average day of the average length of claims handling dropped from 30 to 60 days back to 1 to 5 days. So this was a considerable improvement achieved in Suncorp. In the Queensland government, we applied the visual miner and found found several deviations that were happening in reality compared to existing models that were made there. And this was in the end used to identify opportunities for robotic process automation. Now, this is just a few projects that have been performed within the BPM group here at QUT. And well, okay, one final one, and we also applied this to Queensland University of Technology, QUT. Here we studied the journey that PhD students traverse in terms of their milestones. So think of stage 2, confirmation and final thesis submission, and taking leave. We studied this process and found that there were some differences between faculties, and this led in the processing of these forms. And several changes have been proposed to address this and to kind of adopt the best practices that we identified. Now, the visual miner itself is actually sold by Hitachi Consulting. So they offer it as a cloud service and offer this and sell this to their clients mainly in beef supply chains. And Celonis, who is currently the market leader of the process mining commercial world, also uses technology from the visual miner in their product. There are some other industries where it was applied, not by us, not by others. So if you would like to know more about this, then please see the website visualminer.org. Because what I would like to move on to now is a bit of the cutting edge, or what are we currently working on and where do we want to go in the future. So a bit back to theory. Every process mining tool and every process mining model that I've shown you up till now gives a yes or no answer when you ask the model, does this trace occur in your behavior? So a model describes a certain behavior, and then you can ask, do you support this trace? Then you get a yes or no answer. However, for more of the advanced uses of process mining and the novel techniques that are being developed there, what you need is a likelihood of behavior. So for prediction and recommendation, you can probably imagine that you need to know how likely is it that this path through the process is going to be taken next. Now, in order to assess that, to have that knowledge, you need a stochastic process model. So a stochastic model, if you ask a stochastic model, do you support this trace? Then the stochastic model will give you an answer between 0 and 1 with how likely it is that that trace is going to be produced by the stochastic model. Now, this changes quite a few things in process mining and will keep us busy for quite a few years, because now an event log is not just a collection of things that have happened, but it is actually a distribution of traces. How likely is it? So you can imagine that we need to redo discovery, we need to redo conformance, and we need to redo enhancement. All because stochastic models are a completely different nature. We are actually working on this based on questions from an industry partner, a superannuation service provider in the Netherlands. And what they are after is they want to improve the customer satisfaction through process improvement. So people call this superannuation provider and they have questions, or they get letters and then something is unclear and they call. All of this is logged in information systems and in event logs. And what they would like to do is improve the customer satisfaction, because the market is being liberalized. So they need to compete now on customer satisfaction. In order to do this, one thing that is currently missing, why we cannot do this analysis yet in the shape that we would like to, and what is actually the future work that we are now working on with the people mentioned below, is can we correlate process with other variables? So is there a correlation between customer satisfaction and the process that they follow? That's the first question. And then in order to answer that, of course, this industry partner is not just interested in this correlation itself, but whether these results are statistically significantly different. That is what we are currently working on for stochastic process models. So yeah, surprisingly enough, this doesn't exist yet in process mining. Another cutting edge thing that we're currently working on and that we will use for future work is to combine process mining with data mining. And here Hitachi Consulting comes back. What Hitachi Consulting does is they look at the supply chain of beef, not for a single farm, but for the whole supply chain. So cows, they are born in certain farms and then they are moved to different farms to grow. And that happens a few times to reflect different stages of the cows. And in order to optimize that and make sure that they get the highest return on investment. So in order to do this, they are measuring a lot of sensor data on farms, and they would like to know how cows move through this supply chain. So when are they moved to the next stage, or are they moved back to a farm at some point? That's the types of questions that they would like to answer. Because each farm takes these decisions, of course, in isolation. So it would be interesting to see the supply chain as a whole. So at the moment, and here we see again a figure of the visual miner. This model is a process model. However, what we would like to do is combine that with data mining to see whether certain decisions are influenced by data and how data is influencing progress through the process. So this is a typical example of where process mining alone doesn't cut it, data mining alone doesn't cut it, so we need to combine them. Another area of where this becomes relevant is in healthcare. So right now with the COVID-19 situation, doctors in emergency departments or intensive care units, they have to decide, am I going to intubate this patient? And that intubation means that you get a big plastic tube in your throat, and then you are being ventilated. So you're being kept alive by a tube. Now, this is, of course, not an easy procedure and very delicate. So doctors would like to know, when do I have to intubate this particular patient? And that depends on a lot of factors. And what we are doing is we are developing a risk score of intubation of respiratory problems that will help doctors to take this decision. Of course, I wouldn't dare to claim that we're gonna take the decision for him, but yeah, the main problem we're solving there is a doctor at 5 p.m. can decide, do I go home now and risk being called back at 2 a.m. With all sleepy and less experienced staff around me, or do I do it now and just be safe? That brings me to the end of my talk. So you have been watching. I've shown you the inner workings of process mining and what it is used for. I've shown you a demonstration of the visual miner. I've shown you challenges in process discovery and why this is interesting from a theoretical perspective, because it is not possible, in many cases, it is simply not possible to find a model that is perfect in all circumstances. It depends on the use case. I've shown you that we are working on stochastic process mining and on the combination of data mining and process mining. So maybe as an end conclusion, we want you, if you are familiar with statistics and data mining, then we are looking for collaborators to help us to solve the issues that we see and that our industry partners also see. Thank you, and I'm glad to take any questions.
Thanks very much, Sander. That was really interesting. Actually, I didn't know anything about process mining before this presentation, but yeah, it's definitely opened my eyes to this area, which is really interesting. So there was one question that came through in the Q&A chat. And so this question is from Marty. In the field of process mining, a suitable one for students with industrial engineering or management background? That's the first question. And then the second part is, or do you suggest our students should have a computer science background? So basically, what background do you think that students have that would be suitable to go into the area of process mining?
Yeah. Thank you for this question, Madi. What I've talked about today in this talk is, of course, very tailored towards computer science and mathematics. However, process mining is actually on the border between several fields. So I've already mentioned computer science and mathematics, but industrial engineering and management, they could actually benefit from using process mining and go for data to move from let's say PowerPoint management. I'm a bit charging now, I'm provocative, but I think I can do that. Towards let's say evidence-based analysis. So process mining is very broad. So it's not limited to just algorithms. There are far more aspects to it. So think of like how how do you derive insights from the things you see using process mining tools. That's one area that we currently studying here in our group as well. Like how do people use process mining tools effectively? How can you go from, okay, now we have this tool, to actually implementing it in in an organization? How do you visualize things in processes? So that there are a lot more aspects to this than just the die-hard computer science side.
Thanks, Sander. It's definitely good to hear that there's many different disciplines that can sort of get into process mining. So there's another question, this time from Damien. Any comments or observations on the work required on event logs to normalize, standardize them to give rise to insights using process miner in a commercial sense?
Yeah. So in this talk, I've kind of pretended that this event log is magically there, but of course it isn't. So a bit of a rule of thumb is that 80% of the time of a project is actually spent on getting this data. So in our observations, this is also what takes the most time if we work with industry partners. Like, first of all, getting the data is usually challenging because of NDAs and buy-in from management that you need, and then yeah, it's not part of daily operations, so it might be challenging to get people to commit to actually get the data. Once you get the data, then usually it is not. Let's say the challenge then is to identify what process am I going to study. So once you know, like if you've identified the case ID and the activity and the timestamp, then after that it's merely a matter of going for writing that into the CSV, and then like the standard programs take over. So for instance, in the commercial tool Disco, if you have a CSV file and you know the columns, you can just say, okay, I want this column to be activity, I want this one to be timestamp, and so on. So the challenge is really more into getting the data than to normalize or standardize them. Having said that, a whole new study of data is data quality. So there's a lot of research going on around what are now data qualities. So for instance, what we have seen is that nurses in a hospital, they write down the procedure that they've just applied on paper, and in the end they get put in a system. But then of course the timestamp is not correct, so you need to abstract from the minute or the millisecond because it doesn't make sense. You have to limit it to a day. So all these kind of issues all show up all the time. Yes.
Thanks, Sander. Actually, there's another question that's come in from another student. So it looks like you might be getting some PhD students out of this talk. So that's a good outcome. So the question is, so this student has done some courses in process mining, has a background in industrial engineering, done some courses in statistics and data mining. So do you have any suggestions of how to sort of like get into research in this area? Like, so what's the best sort of pathway for research?
Yeah, I think this question I can best answer maybe offline in an email or something. So Huang, if you would like to drop me an email, I think I can better help you. So of course we are taking PhD students, but yeah, no admission requirements. I mean, yeah, I think let's do this by email.
Yeah, that's a good idea. And so we have a question from Richie, and Richie's one of the program directors in the Centre for Data Science. So Richie's question is, do you use established predictive data mining algorithms, such as decision trees, as an underlying model? And if so, what are the successful algorithms and models in this area?
So predictive process mining. So that first of all, thank you, Richie. There are several aspects. So the things I've shown you in this presentation do not use standard data mining algorithms. Where they are used in combination with process mining is in if you want to one area of research has been to see in a process model what influences the decision. So if you have a decision point in a model, you can see which traces go left, which traces go right. Then I think their decision trees have been applied in order to study that more. However, I am not familiar enough there to say anything about how successful they were. Where we would like to apply data mining algorithms is more as a means of sequence. So, for instance, in the intensive care that I talked about, like there is a heart monitor that's constantly being recorded, and there's oxygen levels that are being recorded often, and blood tests that are recorded every so often. So can we combine those into kind of a decision making? So can we transform that into a risk score that a certain activity in the process is going to be executed in the future? That's what we're after, and at the moment we don't know yet how to do that. So here we are really, yeah, we would appreciate input in that regard.
Thanks, Sander. So if I can actually just ask a follow-up question to that, because some of the participants here are interested in statistics. So what do you think are the statistical challenges in this work?
That's a very good question. Like I said, I've been I put on the slide. I've been working with James McCree now for a little bit on the statistical test for process mining. So what we want to do, for instance, is I have a process model and I have an event log. can we now say that with statistical significance of 95% or whatever, is this log derived from this model? So you would say pretty standard, but traces do not fit any of the standard statistical data types, because they are not ordered, but they have a distance. So that's one thing. And another annoying thing that really doesn't, as I understood, doesn't fit anything in statistics currently, is that we have approximate matching. So if the event log contains a trace that is not supported by the model, then any statistical technique will tell you, yeah, the chance that this log came from this model is 0. But that's not what we want in process mining, because we have noise, we have people writing down things. So that there are quite some challenges there that are to be solved. Yeah.
Yeah, that all sounds really interesting. So we have another question.
Very challenging.
Yeah. So we have another question from Damien. So Damien's question is, can you share any of the type of data and the ultimate results from the beef industry project?
Yeah, the answer is yes. So we always, of course, so the type of data, so this is a project that is basically starting up now. So the results I will have to share at some later point. But the type of data is that we know which cow was at what farm at what moment, and we know some of the conditions on that farm. So rain sensors, sunshine sensors, they have mass, biomass estimations. So that's the challenge there is the combination. So we have process data, cows moving through its process, and we have detailed data around the particular stages in that process. So that's a bit of the challenge there, and that's why it falls nicely in between process mining and data mining. So yeah, I think that's the type of data that would be yeah, and then of course, yeah, we don't have results yet. We are still looking like in the initial phase of the project.
Well, Sander, you managed to get through your entire presentation plus all of the questions, and you've still managed to do it with 5 minutes remaining. So well done there. So I think, so given that there's no more questions, we'll leave it there for today. And thanks again, Sander, for the excellent presentation. It was a really great overview of process mining, and yeah, I think you're going to get a lot of people interested in this field based on that presentation. So thanks a lot again. And thanks everyone for participating, and hope to see you again at the next installment of the Under the Hood seminar series. So thanks again.